Actually, Mr. Psychosis, you should be able to figure everything out from the book. I think not even attempt to. So I'll tell you which section to go. Just look at the example. So so last year, remember we did polar functions. R, beta, and sketch. R is 0, and then we plotted blah blah. Yeah. And then what we're learning here is a little bit of calculus. Let me show you what it is.
I mean, I can't believe you said it. No, I mean, you started doing it. I did my job but I'm saying,
Come back to
that's scary. You mean like, yeah. I was like, what?
You call me Ariel.
If you do the work.
Yes. What the hell?
So 9.4.
He's like,
oh, you're not doing this.
Now what?
I forgot.
Okay, guys. Okay, guys, shh, everybody, stay with me, please. You're learning a. Oh, Johnny's not here. Ms. Mendoza, you're gonna come and sit here. You're gonna abandon. Do what everybody has done. Abandon Mr. San Diego. San Diego, you're come closer. Mendoza, you can see the boat.
He's like,
Torres is not here. Oh my God, I was missing you now. It's like this is a brand new lesson. What the hell? Mr. Psychosis, you can go to. Oh, why don't we do this? Why don't all of you follow me? Let's go wish Baylor. Baylor's back.
oh yeah.
Let's go wish Baylor.
All of us?
Those of you had Baylor?
Yeah. Oh yeah, we did.
Oh yeah.
No, those of you who
Yeah.
Those of you who had
Let's go wish Baylor.
Let's go wish her. I wish Baylor. Happy Baylor. What?
Yeah, he's back. So you can sit in front of me. Close the door on this.
Are you gone?
We're such an interruption. We're such a distraction. We should just not do this one. We're such a distraction.
No more time. Just put our heads down. Go to sleep. People will do time out.
Guys, so everybody, go to me please. For those of you who did Pre-Calc 2 years ago, pay closer attention. So the concept is called polar functions. Repeat, polar functions. So the concept is Miss Marzouk and Miss Rio, you're learning this for the first time. You've never seen this. So I don't believe Xana does this. But just play along, Alright? So the concept is polar functions. So write down an notebook, polar functions. So the polar functions in general, see this vaguely comes back. We have r comma theta. Now here's the definition of r. R is, you'll be tempted to say radius. It is incorrect. R is not the radius. It is basically the distance from the origin. The definition of R is distance from the origin. Okay. Theta, as usual, is the angle. All right. So if you had IM3 or PCAL last year, even the year before that, with Ms. Velo honors, this should come back to you. All right. Let me do graphing polar coordinates. Say graphing. So I'll do two examples, see if it comes back very, very quickly. So assume we are graphing this number, say 5,7 pi over 6. I'm going to show you how, see if it comes back like in 10 seconds. What's 7 pi over 6? 210 degrees, and that's a radius of 5. So I'm writing r comma theta. So technically 210 is here, 210 is here. See if this comes out. 1, 2, 3, 4, 5. And that's the point. So it's like circles really. Okay. You can draw it once, but you'll never draw it again. But really they're like concentric circles that have a radius of 5. So that's the point. Okay. Now let's do a more relevant problem for us, for calculus. Let's graph a point. This should come back to you from last year. Say negative 4, comma 3 pi over 4. Where's 3 pi over 4? Second quadrant, 135 degrees. And the radius is negative 4. Now you're learning something new or reviewing something new. See if this comes back. This is 1, 2, 3, 4. Who remembers from last year, what do you do if you have a negative 4? You switch it 180 degrees. So it'll go to this one, 2, 3, 4. This is where P is. To be clear, when do you do this? If you have a negative radius. You have a negative radius. So draw an arrow. So plot the positive and then flip it 180 degrees, just diametrically across. Does that really come back to you guys?
Yeah.
Okay. So that's how you plot polar functions. Now we are going to directly jump in. A lot of these are new problems. We did not do them even last year, but it's okay. The same principle applies. So graph. Copy on the first question. The homework is pretty much done. I just have to edit it, see there are no typos, and hit send. So it says r equals theta. So for those of you who have forgotten this, the values of theta we choose, see if this comes back, are, look at me, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Is that clear? Those are the values we plug in. So play along with me. This problem should take maybe 45 seconds. Initially, theta is 0. So what should r be? Initially, theta is 0. So what should r be? 0. So it's here. So label it 0. Next, so I'll just count in multiples of pi over 2. Next, theta is pi over 2. So what should r be? Now stop, we'll make estimates. What's pi roughly as a decimal? 3. Over 2? 1.5. So see if this comes back. It's roughly here. Okay, that's pi over 2. And I will start graphing it. I'll start graphing it, so it's going like that. An arrow helps you, so it's going like that. 0, pi over 2. Next, theta takes the value pi. So r should be, so what is pi roughly? 3.14, slightly over 3. At pi is 180 degrees. 1, 2, 3, slightly over. Label, this board. 1.5. That's all. Look at this. Okay, let's try it again. This is getting really annoying. I even cleaned it on Thursday, Friday with Ms. Bailey. Okay, it's slightly better now. Okay, so label that. Bloody hell! Okay, pi, and then continue there. Okay, just smooth. Okay, just continue there. Draw an arrow. So it's going 0, pi over 2, pi, and then 3 pi over 2. I'm helping you. What's 3 times pi over 2? So what's your decimal? What's pi over 2? So what's 3 pi over 2? 4.5, thank you. So 1, 2, 3, 4.5. That's 3 pi over 2. Let's connect. Wait. that. There's an arrow going that way. And then finally, you reach pi. 2 pi. What's 2 pi? 6.28. 3.14 double 6.28. 1, 2, 3, 4, 5, 6.28, something here. That's 2. That's it. Is that clear? Stupidly easy. So you just plot 0, 90, 180, 270, 360. Plug into the right hand side, you get the left hand side, plot, and you get to go. Okay, let's move on. Copy down 2, please. In retrospect, Miss Dong, I think I should be. But I'll give it a shot. I'll still give it a shot. I'll let you know, okay? The board is all of a sudden malfunctioning. Okay, this is very weird. But we'll use common sense. What value should I plug in initially? 0. What's e to the power of 0?
1.
So is it really -1? Look at me, Rios and Marzu. So when 0 degrees, r is -1. So where am I really? On the left, we flip it 180 degrees. So it's here. And 0. Guys, we did this in the other class. I want you to expand it. Make -1 here. Okay, make that wide. Trust me on this. Just trust me on this. So this is -1. 0. Oh, sorry, I meant 0. Okay, next. What value of theta should I plug in? Pi over 2. What's pi over 2 roughly? 1.5. So am I on the side? Am I finding e of -1.5? Everybody okay? Is that really 1 over e to the power of 1.5? No, stop. We're just really estimating. What's e roughly? 2.7, say 3. So it's 3 to the power of 1.5. What's 3 to the power of 1? 3. What's 3 to the power of 2? 9. Somewhere in between them. Do you see what I'm doing? I'm not touching a calculator. You're expected to graph this without a calculator. So I'm somewhere between 1 over 3 and 1 over 9. Am I making sense? What's 1/3 roughly? 0.3333. It's 0.3. 1 and 1/9 is 0.1. So I'm slightly between them. So it's about 0.2-ish. So am I positive or negative? Negative, that's a negative number. So -0.2. At 90, I'm at -0.2. So where am I really? Below. So now you understand why. So -0.2 will be, say, here. That's pi over 2. What am I plugging in next? Pi about 3. Will that become e to the power of -3? Now stop. Will e to the power of -3, will that become 1 over e cubed? So I have 1 over e cubed. Now common sense, is that number bigger than that? No, is that number bigger than that number or smaller than that number?
Smaller.
So we just need to estimate. So should I get closer then? Do you understand? So 3 pi, I'm getting closer. So make a guess. What about 3 pi over 2? Will I get even closer? And what about pi? Will I get even 2 pi? Will I get even closer? That's 2 pi. And remember, for those of you wondering, can you see each of those is negative? So I'm flipping the numbers. In case you were saying, how are you doing that? At pi, I have a negative number. So should I flip it there? At 3 pi over 2, I'm negative. So long story short, this is your graph. Arrow, pi, arrow, and then arrow. That's what is going. That's 2 pi. Okay, that's 3 pi over 2. I'm really using common sense. If I use Desmos can graph polar functions. The graphing calculator can also graph polar functions. But you're not expected to know that. I'm just showing you what it looks like. Using common sense, just using common sense. Okay, now we'll do what we did last year. Copy that question. So we did these questions last year. I'm going to be fairly swift, so stay with me. So Ms. Lee was working on these problems already doing homework. She was hanging out with me, period 4. She was starting her homework. She's around, I think, me about 40 seconds. You see, remember from last year. Okay, look at me. Let me review concepts from last year. Isn't cos basically the x values on the axis? And y, sine is basically the y values. This is cos, so I'm going to look at the x values here, here, and here. Okay, let's do this quickly. What's cos of 0? Times -3? Take away 2? So at 0, I'm at -5. So where am I really? This way. 1, 2, 3, 4, 5. Label 0. So that we can be faster. I hope some of you memorize it. Cos 90 and 270 are 0. So at 90, what's your radius? Negative 2. So where am I really? Down. Because I'm flipping. So that's pi over 2. Okay. I'll do the arrows later. Pi. Careful. What's cos of pi? Negative 1 times negative 3. Take away 2. Okay, now stop. So at 180, the radius is positive 1. So I'm on the left or on the right? On the left, yeah. Cos 270 is 0. That's negative 2. At 270, I'm at negative 2. So where am I really? Up. It's 3 pi over 2. And then finally, 2 pi cos 360 is 1, negative 5. So when I come back here, I hope it's 2 pi. Now observe the arrows, please. I'm speaking so little more. So I start at 0. I go to pi over 2. Okay? Pi is there. Now see if this comes out from last year. Now I'm looking here, look. I'm speaking. Can you see the inside number is bigger? That's 2 and that's 3. You know the signs. I'm going to recall a concept, look at the board and say, oh yeah, I remember. So if the inside number is bigger, it's called an incardioid. For A plus or minus B cos theta, or A plus or minus B sine theta. So both those functions are cardioids. And it's incardioid if B is bigger than A. The absolute values. If B, the inside number is bigger. So see, this comes back. So in cardioids, I'm going to explain the concept. Go through the origin. So we'll draw a heart. And then who remembers what we do the inside guy? Thank you. We draw a loop. That's the in cardioid. And draw an arrow there. You will pass through the origin. You will pass through the origin. That's like tomorrow's lesson. Today, like religion is accepted. Okay, repeat. If the inside number is bigger, it's called an incardioid. It loops in. Let's go to another problem. Copy down D, please. This is not just a review. This is a review from last year. Guys, I'm helping you. Sine are the y values. Okay, the y values of the points. Sine 0. So where am I really? On the left. 0. Sine 90. Therefore, negative 4 plus 2. Where am I really? Down. Sine 180. 0. So negative 4. I'm on the right. Sine 270, down below. What's sine 270? Negative 4. Take away 2. So where am I really? Up. 2, 3, 4, 5, 6. Okay, that's 3, 5, and 2. It's there. Okay, it's not up here. And then finally, sine of 360 0, negative 4 will come back here. 2 pi. Okay, what's the boundaries? Again, stupid nonsense. Okay, let's see here. 1, 2, 3, 4, 5, 6. Okay, I'm showing you something. Look at the board, please. Do you observe this is negative 4, that's positive 4, and this is short, that's tall? I'm going over the concept. So it's always, you observe the symmetry. The symmetry is left and right, right? Okay, all these graphs have like a butt crack. The shorter guy is where the heart of the butt crack is. So what's the board, please? So it's like that, and then like that. Okay? So the symmetry is right and left. The shorter guy always has the butt crack. Okay? That's something you need to remember. A small thing, I'm giving notes. Look at the board, please. Can you see the outside number is bigger than the inside number? So that's called an out cardioid. So make a note. That's an out cardioid. You just need to be vaguely familiar with those ideas. Don't say, but Rama, that's negative 4. I said this before. We're talking absolute values. That length is bigger than that length. So it's an out cardioid. See, the point is not at the origin, not inside. It's outside. The last of these problems, let's do E, please. So for cosine, am I looking at x or y? Cos 0, therefore 0. Cos 90 is 0, so negative 3. So where am I really? Bottom. Pi over 2. cos 180 is negative 1. So what is it really? So where am I really? On the right. 2, 3, 4, 5, 6. So, I don't know why it's erasing. The hell? That's pi. Whatever. It's pi. Alright. Cos 270 is 0, negative 3. So where am I really? Up, 2, 3. Well, have a look. It switches to like an erasing. I don't know why. Okay. Oh, well. Yeah, that's 3 pi over 2. And look, see, again it switches. Okay, and finally, cos 360 is 1. So 0 again. Alright? So observe the symmetry and draw a cardioid. If you do it correctly, it'll be a perfect heart. Okay? Perfect heart. Aww. So I believe it's like that perhaps? Okay, see if it goes like that. Rios and Marzuk, see if you got the hang of it. Okay? Let's do a slightly more challenging problem. The last two AP exams, 2016-17, these questions are here. So copy down theta plus cos theta. But relax, being a good teacher, we did do this last year also. Do not get alarmed. I have two expressions. I have a theta there and a theta there. Relax, I'll just plug into both of them. Alright? We'll start with 0. That's 0. But what's cos of 0? So it's here. Guys, today, like religion, accept that you need to label 0 pi over 2. Tomorrow you'll understand, oh my god, it totally makes sense. If I do not label the direction, I am going to make a mistake. Actually, even today's homework. We do some problems and say, oh, if I'm not labeling, I won't know which quadrant I'm reading. Okay. Cos 90, guys, we're doing pi over 2. So what's pi over 2? 1.5. Isn't cos 90 0? So it's 1.5 and 90. There. That's pi over 2. Okay, we're going to 180. So what's that number really? Hint, that's 180 radians. Pi, which is roughly 3.14. What's cos of pi? So what is the answer really? 2.14, 2, roughly. 2, slightly over. That's pi. Let's go to 270. Cos 270 is 0. But that's 270. Hint, it's 3 pi over 2. So what is it really? 4.5. And it's positive. So there's no switching. 4 pi. That's 3 pi over 2. And then finally, do the last one, you should put a point. We're plugging in 2 pi. Repeat, we're plugging in 2 pi. Is it 5-point monkey, 6-point monkey, 7-point monkey? 7, because cos 360 is 1, 2 pi there, 6.28, 7.28. 2, 3, 4, 5, 6, 7.28. So this is your final graph. Arrow, 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 arrow. That's your graph. Is that clear? Yeah.
Do we have to draw the arrows?
Yes, it's important. You'll understand if you don't draw the arrows and label, tomorrow's lesson becomes brutally hard.
So also on the cardio.
Yeah, exactly. Okay, now we're doing calculus. Okay, we're coming to actual calculus. I want to skip that. It's the same concept. Okay. So I want you to copy. Oh, well, before you do that, Ms. Dong, actually, if you position the computer here, the board is malfunctioning. Okay, we're doing notes from pre-calculus. So write these notes down from pre-calculus. This is not new stuff. We'll review some formulas. So we'll sketch a figure. So see that point is x comma y. And that's r, and this is theta. This is x, this is y. Okay, when I went over this, when we began the lesson, let's see who remembers. And I'm hoping nobody gives the wrong answer. What does r stand for? Distance from the origin. Do not say radius. It will confuse the hell out of you. There's no radius, there's no circles here. It's the distance from the origin. Okay, so that r is the distance from the origin. Yeah, I will write here. Thank you. It's the distance from the origin. Guys, these are not trick questions. These are basic trick. Who remembers the sine formula? Sine theta equals? In terms of x, y, and r.
Y over R.
Y over r. Can we cross multiply? So see this concept from last year. Therefore, y equals, thank you, r sine theta. Put a box. Okay. Who remembers the cos formula? Cos theta equals
X over R.
x over r. Therefore, cross multiplying
R cos theta.
x equals r cos theta. Put a box around it. Do these vaguely come back from last year? Okay, stare at the board, memorize it. You don't have an option. Stare at the board and memorize it. So I'll say, how do we find x? You'll say r cos theta. Say, how do we find y? R sine theta. How do we find z? Your mom!
Oh shoot.
This is random. It's being recorded. Somebody's going to upload it, and there's some kid who actually goes to some YouTube channel and studies x is r cos theta. What? Z is your mom. Mom! Okay, so these are basic ideas. Okay, I want you to copy down the stem. So do not copy A yet. Copy down the stem for the polar function -5 minus 3 cos theta, and then call out A. Then copy down this instruction. Guys, I'm letting you know. The good news is, Mr. Arnold will tell you the class of homework is stupidly simple. It's extremely calculator driven. It's all calculator driven. You're hardly doing anything by hand. So it's like, can you find solve an equation on a calculator? It's like dumbass easy. So for the polar function and write down A. In that interval, there's a point P for which the distance from the origin is 3. Find it and underline the word and. So Ms. Himpelman forgot, did not see there's a word and. So find it and the corresponding point in rectangular coordinates x, y. So in simple language, it means find r theta. It says find it. There's a point r, theta. Find it and the corresponding point. Now, none of these are tricky questions. They're stupidly simple. And I'll show you how to do them. Before we move on, we're going to do part D first, so you can understand what the problem is asking. Here's part D. Part D just says sketch. Let's do that first. I was just saying, what is going on in this problem? So we're going to sketch that function, the way we did it earlier. Okay, I'm going to sketch it here. Stay with me, please. I'm going to plug in 0, 90, 180, 270, and so on. Cos 0 is 1. So -5 minus 3 is? Where am I? On the left, 2, 3, 4, 5, 6, 7, 8. And that's 0. Cos 90 is 0. So -5. So where am I really? Down, 2, 3, 4, 5. It's pi over 2. Cos 180 is -1. So the distance is really -2. Where am I? Outside? Correct? Mm-hmm. And just a tip. Isn't the outside number bigger? So it'll be an out card here, so we're okay. That's what we expect. It's an out card here. So that's pi. Cos 270 is 0, -5. So where am I really?
Top.
2, 3, 4, 5. 3 pi over 2. And finally, cos 360 is 0, -5, we're back here. Okay. So observe the symmetry. I'm speaking Rios and Marzouk. So top and bottom are symmetric. So it's an out cardioid. It's the shorter guy that gets the butt crack. And then like that. Draw an arrow. That's how the graph goes. Okay, now let me help you interpret the question. Old rules, just like first semester. We'll interpret this using notation. We'll say, oh, that's all we are finding. It says, let's see who's smart. It says, there's a point for which the distance from the origin is 3. See, you can write an equation. It says the distance from the origin is 3. So who can tell me what to write? It's not a trick question. R is 3. Everybody okay there? The distance of the origin is 3. So, isn't R given to us? Can I set that equal to 3 and solve? Okay, everybody take out a simple graphing or scientific calculator. Take out your calculators. Otherwise, if you don't have one, you can use a simple scientific calculator for this problem. Okay, either I encourage you to take your scientific calculator, your graphing calculator, but otherwise a simple scientific calculator will also suffice. So I'm going to solve. R is, guys, we're doing trig. We're doing trig from last year. So -5 minus 3 cos theta equals 3. Look down. I'm going to walk you through it. We're solving a simple trig equation. Next step. -3 cos theta equals 8. Next step. Cos theta equals negative 8/3. And stop. And stop. Nobody speaks. I can waste my time and use a calculator, but just by looking at that, I know the answer is no solution. Somebody tell me why. Raise your hand when you figure it out. I can do the math. I can use a calculator, hit cos inverse. It'll give me domain error. But some smart fellow tell me, without even touching a calculator, looking at those numbers, I know the answer is no solution. Somebody tell me why. Ms. Romero? Thank you. She smartly observes, isn't that x over r? Can x be bigger than r? So the answer to that is no solution. And stop. Now I'm blowing your mind. I'm blowing your mind. Look at me. You're learning. The answer to this problem is not no solution. Look at the board, please. What the question is saying, the distance from the origin is 3. Watch. I'm showing you what's going on. Is the distance from the origin 2? Is the distance from the origin 8? Is the distance from the origin 5? And it says in pi to 3 pi over 2. Nobody speaks. Figure out based on what we do. Where is pi to 3 pi over 2? Where are we? Is that quadrant 1, 2, 3 or 4? Pi to 3 pi over 2 according to us.
1.
Is that quadrant 1? Does everybody get it? Do you now understand why it's important to label? Mind blown. Their thing is different from ours because it depends on where we began. Now let me show you why in quadrant 1 you must have a distance of 3. Look at me. Is that distance 2? Is that distance 5? Somewhere along the line, should you not have it? Maybe somewhere here, hit a distance of 3 because you're becoming 5 there. That's 2. Should you not have reached 3 there? So here I'm blowing your mind. So the distance, so the answer no solution doesn't make any sense. We totally have a solution. There's a solution here too. But we want this guy. Nobody speaks. If you're insanely smart or you have a good memory from last year, tell me how we fixed the problem. We did this last year too. So we tried solving that. We got no solution. But that clearly has a solution. So we're doing something wrong. Who can fix the problem? In the other class, I think it was Mr. Sitton. Who answered it? One of the other, or Masharia. Oh, I think it was Masharia. And actually, here's how praiseworthy that is. He took the class 2 years ago. Or was it last year? No, 2 years ago. He figured out how to do it correctly. We start solving the problem, we get no solution. And you get no solution. No, but there is clearly a solution. Look at it. Anybody? Anyone? You're going to be wrong, but I'll correct you. Yes. No, we are going to do inverse on a calculator, but this is clearly no solution. What math allows you to forcibly change it to positive? Just make it positive? If you don't get an answer, make it positive. But why? Just make it positive. Anyone? Okay, guys, now I'm telling you the answer. Isn't r the distance from the origin? The distance from the origin? But could the distance r not also be negative 3 and the distance will still say 3? How many of you understand what I'm telling you? It says the distance of the origin is 3. Could r have a value of negative 3? That just means you flip the distance, right? You just flipped it across. So make a note. Go back to that, distance of the origin. Make a note to yourself. R can be plus or minus 3. Make a note. So that's how we correctly do the problem. Make a note. So distance, if distance is 3, I'm helping you. If the distance is 3, r can be plus or minus 3. But the distance will still say 3. So I'm going to change the problem. So negative 5 minus 3 cos theta equals negative 3. Next step. Now the answer will show up. Add 5, negative 3 cos theta equals 2. Cos theta equals negative 2/3. Is x smaller than r? Okay, let me show you this from last year. Guys, I expect you to do, look at me. All students take calculus, sketch figures and so on. That's basic trick. But let's do this on a calculator. See, this comes back, theta r. This is a calculator problem. See, this comes back, cos inverse. Just 2/3. Do not have the negative sign. Now grab your calculators, and type cos inverse 2/3. Hit cos inverse 2/3. Give me 4 decimals, quick. 0.8411. Yes? We're not done. That's only the reference angle. We need the angle, look at me, this is a trick that you will have forgotten. We need the angle in the third quadrant, pi to 3 pi over 2. So who remembers, if I'm from pi to 3 pi over 2, I know theta to be 0.8411. But I need this angle. Who remembers how we adjust it? Add to, I need to be in radians. Pi, thank you. So make a note, some of you have forgotten this. Over here, you do pi plus. Who remembers from here what we do, if I know the reference angle? Pi minus. Who remembers what we do here? 2 pi minus theta r. Pi plus theta r. Pi minus theta r. Over here it's just theta r. See, that comes back. So in your notebooks, can you please do 3.14, or your calculators have a pi, or 3.1415 plus 0.8411. So tell me the angle, please. Just add pi to that. 9826. So look at the board, so we solve the problem. Look at me, so you understand what we are. It says there is a point r comma theta. So I need r and I know theta, for which the distance from the origin is 3. So do we know r to be 3 comma? So the first problem has this answer. Look at the board, please. So r comma theta is basically negative 3 comma 3.9826. Is everybody okay there? R comma theta. We found r, we found theta. Yes.
How do you determine whether R is positive or negative, or do you test both?
Yeah, we test both. Oh, I love you. She remembers. Guys, she says, how do you know it's positive or negative? This one was easier. We tried positive, it didn't work. We switched to negative because the distance is very similar like distance earlier. Distance is the absolute value. It can be positive or negative. Okay. But sometimes positive and negative works, you'll account for both. Okay. Let me speak slowly. Arnold, I did not discuss this in the other class. Sometimes R can be positive and negative, and both roots will work. So you may have 3 answers or 4 answers, and that's okay. Okay. Now, so we did this. Find A. The question then says, find the corresponding point in rectangle coordinates x and y. Okay, let's see who can answer as a chorus. What's the x formula? R cos theta. What's the y formula?
R sine.
R sine theta. Do we not know R?
Yeah.
Do we know theta? Mm-hmm. We're just going to plug it in. Your calculator do it. We're not going to do it. I'm just showing you. So make a note about what we needed. X comma y. Formula, plug it in. Stupid listen. We're not doing it. I'm sure showing you how to do it. It's very formula driven. Today's class of homework is very formula driven. Okay, copy it on B, please. Copy down only this step. The homework is extremely short, extremely easy. But make sure you do it. Audace, do your bloody homework. He's like, maybe. He's going to look outside the window, see the planets are aligned. If the planets are aligned, he'll do it. Otherwise, nah, duck it. Audace, but seriously, man, stop being lazy. Okay, let's see who's smart. They say there's a point x comma y for which x equals 1. Okay, they're telling you x equals 1. Write me a left-hand side, please. Write me a left-hand side. Let's see if you're alive. Okay, those of you with advanced skills, what are you writing on the left-hand side? R cos theta. What's R after all? Thank you. Is that... No. This is a different problem. This has nothing to do with the previous problem. Look at the board. What's R after all? No, look at the board. What's R after all?
Oh, negative.
There you go. Negative 5 minus 3 cos theta times cos theta equals 1. Now I'm letting you know this is a calculator problem. Which bright fellow will tell me how to solve this on a calculator? Nobody speaks. Everybody knows how to find it. How do we solve that equation on a calculator? Ms. Marzouk? Okay, move the 1 across. Negative 5 minus 3 cos theta dot cos theta minus 1 equal to 0. What do we do, Ms. Marzouk, on the calculator? And then find the x-intercepts. So make a note to yourselves. Find the x-intercepts. Now some of you will say, Rama, how do I plug this into a calculator? Relax. Look at the board, please. I'm speaking. Is that just an x on your calculator? You're just finding the root. Don't get alarm at theta. You can just call it x. Find the x-intercept. Now, just to make sure everybody gets it. Again, it said the x value is 1. Okay, x is r cos theta. Plug in r, plug in cos theta. Get everything to one side. Use your calculator, find the root. Okay, but stop. Do you observe? Look at me. Do we not need the root from 0 to pi out to make sure you find the correct Everybody. Arnold, I forgot to emphasize this in your class. Make sure you're finding the correct x-intercept. It's in that interval. Just to make sure everybody gets it, when I find the x-intercept, what am I finding? It is giving you the value of? It is not a trick question. When I find the root, it is really what? Theta! Thank you, you're finding theta. Make sure you understand that. You're finding theta. Okay, now read the question. What do we need? Read the question. What do we need? Find what? X and Y. So, we need X comma Y. Be alive. What's the X value? 1. Be alive. Be alive. And how do we find Y? Plug it in where? R sine theta. Just be alive, guys. We know theta, we know R, we can plug that in here. Stupidly easy. Just be alive. I need R. Why is R sine theta? Plug in theta there, sine theta there, multiply, your calculator will do it. It's extremely formula driven. Just be alive. Okay, all of you, copy it on C and figure out how to do the problem. Here, you copy up. Control Z. Will that do? No, not reload. I meant redo this page. Sorry. What part are we on again? C? Okay, this belongs there. Okay, there you go. So just copy down this information. C, do 3 steps all by yourself. Like this is what I'm going to do. Ask me. No, when you find the x-intercept, I'll give you the theta value. Correct? And I need x comma y. X is 1. The question gave you. Y is r sine theta. Can I plug in that theta into that guy? Sorry, sine theta. R we know, that's sine theta. Just plug that in to your calculator. Just type it in. -5 minus 3 cos monkey times sine monkey. Whatever that is. Your calculator is doing all the math. Okay. The previous problem I said x equals 1. This says y equals -2. Show me 2, 3 steps. Like this is what I'm going to do. I'm going to pick on one of you. It says in the second quadrant, pi over 2 to pi, there is a point x comma y such that the y value is -2. Ms. Babar, tell me what you're writing.
Y equals r sine theta, so then r sine theta equals -2.
Next step.
-5 minus 3 cosine theta times sine theta equals -2, and then move the 2 to the other side.
Stupidly easy. Can I use my calculator to find the x-intercept here? Don't forget, that will give you a theta value. And then, can we find x comma y? Just making sure you're alive. Making sure you're alive. What's the y value? -2. Do I just need to have one more calculation? And how do we find x? R cos theta. Plug into R cos theta. Stupidly simple. Very formula driven. Okay, we did D. Okay, now we're coming to calculus. Now, those are just basic ideas. Now we're coming to calculus. Copy down the question, please. So remember, if they say slope of the tangent line is dy over dx. First semester. So I'm going to discuss a concept or formula we discussed in the first semester. See if this comes back. Okay, I'm writing here. Isn't x, sorry, let's do y first. Isn't y nothing but r sine theta? And as Ms. Babar said, what's r really? -5 minus 3, what's it cos? Dot sine theta. Same way, what is x? So is it -5 minus 3 cos theta dot cos theta? Is everybody okay there? Nothing profound? Okay, now comes the big reveal. Now y is a function of theta. So can I easily find dy over d theta? Can I take the derivative with respect to theta? Play along. Likewise, easily, can I take the derivative of that with respect to theta? Can I find dx over d theta? Is everybody okay so far? Okay, now magic appears. I did not teach this way in the other class. In the other class, I just shared it. For you, I'm going over like, we can do this. Okay, what simple arithmetic operation can I do with these two guys to get that guy? Nobody speaks. What simple arithmetic operation? I know dy over d theta, I have dx over d theta. Should I add, subtract, multiply, divide? Do that, I'll get dy over dx. Divide. For those of you who don't get it, write it down. So that's dy over d theta over dx over d theta. Let me show you why the math will work out. How do we always divide fractions? So I'm doing a sidebar, so you understand why. I'm not writing here to clutter. Sidebar. So is that actually dy over d theta times d theta over dx? And what do you observe happen? You get dy over dx. So arithmetically we're okay. So put this in a box, please. This is the formula for slope of the tangent line. So if you see the word slope of the tangent line, derivative, you're using that formula. Is that clear? Okay, let's do it together. We're going to do that. Everybody, look at me. So we already wrote y, we already wrote x. I'm going to take derivatives. Which simple concept am I using? Louder? You're correct. Say that louder, man. Product rule. Do we have product? So I'm going to take product. So stay with me, do not fall behind. So keep the first guy fixed. Look down. Times cos theta plus, keep the second guy fixed, times, careful, what's the slope of negative 5 minus 3 cos theta? Is it just 3 sin theta? Because 2 negatives make a positive. Over, okay, I'm directly plugging it in. I'm taking the derivative of x. Product rule again. Again, dy on top, dx on the bottom. Negative 5 minus 3 cos theta, Mr. Wen, look down, times negative sin theta plus times 3 sin theta. Is everybody okay there? Guys, look at me. That's it. Find the slope in terms of theta. Yeah, totally. We're done. Stupidly simple. Dy over dx is dy over d theta over dx over d theta. There's nothing more to be done. Really, if this is a multiple choice question, this will be one of the choices. It's okay. Stupidly simple. Memorize it. It's easy. Actually, we'll do G before F. Write on G. In the other class, I made it easy. Make it pi over 2. Change the problem. Make it pi over 2. Okay, put your pencils down. You guys know how to do this. Look at me. I need the equation of the tangent line to the curve. What are the two things we need to write the equation of the line? What's my point? What am I writing here and here? What's my point? You have to be louder, Javidi. You're right. X and Y. Everybody okay there? So write down point. Smart kids, you know that. How do we find X? Do you understand how repetitive it is? Isn't X nothing but r cos theta? Which is this guy? We already have it here. Okay. Theta equals pi over 2, correct? Let's do some mental math. Actually, is that obviously 0?
Yeah.
Because what's cos of 90? What's 0 times anything? Okay, that is 0. Not too bad at all. Okay, how do we find y? R sine theta. Is that this guy here? Okay, look at me. Is the whole thing 0 or only one of the terms is 0? Is that only 0? What's sine of 90? What's what? Careful. Look at me. What's 1 times negative 5? Negative 5. So that's negative 5. So what's your point real?
0, negative 5.
0, negative 5. Is everybody okay so far? We found the point. What else do I need to find the equation of a line?
So,
Wait a second. It's not that guy. Okay, so make a note. Slope is nothing but dy over dx. at theta equals pi over 2. Relax. Most of these will collapse. Put your pencils down so I can walk you through it. Everybody, look at the board. Will this whole thing collapse?
Yes.
Because of that guy. Okay, what's sine of 90? What's sine of 90? So final answer, on top, so write it down. So 3 on top. Okay, very quickly, will this guy collapse?
Yes.
Okay, will this guy, second guy collapse? Will that guy collapse?
Yeah.
So what's negative 5 times negative 1?
5.
So over 5. Can you write the equation line? So final answer, y
Plus 5.
plus 5 equals
3
3/5 x.
Yep.
Is everybody okay there? Not too bad. This is a stupidly easy lesson.
Yeah.
You have most of it in our calculator. We have like 2 more parts to do. Okay, stay with me, please. Okay, copy the entire problem now. Again, it's extremely short, extremely easy. Make sure you get calculator practice. If you correspond with kids from last year, Nava, Fino, they'll say, yeah, every problem takes about 3 minutes to do it carefully on a calculator. Do you guys want to come in? Okay, come on in, quick. Just sit in the back. Sit in the back. Yeah.
Well, I can't charge my phone.
Guys, you'll have to help me. Does anybody have a charging cable? I have none. If you borrowed a charging cable, there are kids borrowing every day. Or does you have a charging cable? Okay, does anybody have a charging cable? Because I don't have any. We began the school year with 20-25 charging cables. I have like 0 left. Some of you are hoarding charging cables or you're selling them on eBay for $2. Shipping is $5. So you're going on a loss anyway. Pretty stupid. No, I don't have any. Yeah, I really don't have any. Okay. I'll be with you in Balloon. Okay. Did everybody get it? Okay. Yeah. Everybody, look at the board, please. I'm helping you. Write me an equation. I'm helping you. It says there is a point in the second quadrant where the slope is 3. Write something down. It's not a trick question. Interpret it exactly the way it's written. It says where the slope is 3. Those of you ahead, what are you writing? dy over dx
Equals 3.
equals 3. Everybody okay there? It is a calculator problem. What am I doing next step? Thank you, Ms. Marzuk. She can actually, sorry, SSG Marzuk. Should we move the 3 to the left? Wait a second. What's this guy? Who can tell me? What's that guy? Sorry? No. 3 over 5 was for pi over 2. It isn't always 3 over 5. What is dy over dx? Where is it? Sorry? Yes, Ms. Rios is right. It's this crazy guy. Do you understand that? That's dy over dx. And then minus 3. So make a note. Dy over dx minus 3 equal to 0. The AP actually asked these questions. Now look at me, please. I'm just going to show you how to plug this into your calculator. First of all, what we discussed earlier. Aren't all the thetas basically x's? I just want to show you one small thing. In your notebooks, please write down when you're typing this in your calculator. 1 parenthesis here, another parenthesis here. Why? So that order of operations will apply. And then 1 parenthesis here, another parenthesis here. Minus 3, and then find the x-intercept of that. It is a crazy expression. This whole thing on the top, this whole thing on the bottom, minus 3. And I'm letting you know I have one question like this on your chapter test. So you get practice using a calculator. Relax, the calculator is going to deal with it. You just type it in carefully without making errors. Alright? We did that. Okay, copy down H. Can you copy down H and I together? Copy down H and I together. H says horizontal tangent. I says vertical tangent. Guys, first semester concepts. Let's see who's smart in first semester. Raise your hand when you figure it out. I have the slope expression. Repeat, I have the slope expression. Nobody speaks. Raise your hand when you figure it out. If I want a horizontal, shut up. It's Sidon raising his hand. He's in the other class. Okay, nobody speaks. I'm giving you thinking time. If I have a horizontal tangent, in general, don't think of like, no, in general, if I have a horizontal tangent, what should be true? Nobody speaks. Okay, anyone wants to have a shot?
The slope is 0.
Slope is 0, thank you. But stop! Look at me! Don't I have a numerator and a denominator? Who remembers the shortcut in the first semester? If I have a numerator and denominator and the slope is 0, I only say that out loudly. Set the top equal to 0. So make a note please. For horizontal tangent, set the top. Think before you answer. Was that dy over d theta or dx over d theta? Dy over d theta equal to 0. Can you calculate and find the x-intercept for that? Everybody okay there? Once again, what I told Mr. This thing. Observe, I need the first four quadrants, 0 to 2 pi. Okay. Now, if you understand this, let's do I together. It says vertical tangent. Nobody speaks. If I have a vertical tangent, I'm helping you. Look at me. I'm helping you. If I have a vertical tangent, what should the slope be? Undefined. So I set the bottom like a vertical asymptote. So make a note. Set the bottom, which is dx over d theta, equal to 0. Stupidly easy, the calculator will do it for you. You're not doing anything by hand. Maybe the last problem of the day. Oh, no, we have 2 more. Copy this down, please. This is a 30-second problem. Baker, come on in. Zachariah is waiting for you. Zachariah, where are you?
Holding the whole class behind Rama. Can you let them go home, Rama?
Shut up your face.
No.
Kayata le boca. Random dude. I don't know this guy, so I just call him random dude.
He's in Woods class.
Okay. Okay, copy that down, please. Okay, I'm testing basic calculus skills. Challenge. Interpret that phrase in notation. It says, I'll give you a hint, it's related rates. It says, how fast is the distance from the origin changing? Nobody speaks. Write something down, notation. So what is the question asking for? Hint, it's related rates. How fast is the distance? Okay, Marquez. You're the one who just gave a high five. So how do we interpret it?
It's dr over
Related rates.
t.
Thank you. So underline that phrase. It's dr over dt. Everybody okay there? Look at me. So should I just go to r and take its derivative? And isn't r nothing but -5 minus 3 cos theta or something? Okay. Chapter 2, first semester. I'm just going to take the derivative with respect to time. What's the derivative of -5? Okay, careful. What's the derivative of -3 cos theta with respect to time? Tell me what to write. 3 sine theta. Okay, now observe. Have they given you the angle? Is that 2 pi over 3? Can I plug it in and find that? Have they given you d theta over dt? Stupidly easy. Okay, they give you everything. Just follow. Okay, último problema del día. Último problema del día. I want you to copy down this guy. Okay, copy that please. Shh. Park, you can sit down, you know. Do you wear glasses? You look weird without glasses, man. I was saying, why is he looking really weird? Okay, copy down 3. Shh. Ignore this function. This one is on your homework, so ignore that. Okay, and then continue here. The question continues here. Repeat. You ignore this. You copy that down and copy this down. Okay, sit and answer this in the other class, I believe, if I remember right. Well, how do we interpret this? It says find the value of theta in that quadrant with the greatest distance from the origin. So, in that interval, so what concept is being used? You're correct. I love you, man. Say that loudly. Because what is the concept involved? We're finding the absolute max and absolute min. Write it down in your notebook. So we're really finding the absolute max of distance from the origin. What letter? R. Thank you. Absolute max. Greatest distance. Absolute max of R. So should we consider critical points and endpoints? What's the endpoint given to be? 0 and pi over 2. How do we always find the critical point? We set the derivative equal to 0. Is that just dr over d theta equal to 0? Everybody okay there? That's a calculator. The calculator will do that for you. We're not done. What do we do in the last step? I need the largest distance. Plug it into which function? R, thank you. So make sure you write evaluate R of theta. So R of 0, R of pi over 2, and R of that guy, monkey. Is that clear? You can hang around if you have any questions, but otherwise we're done. Thank you. And we are D. Thank you. So, no, I want to talk to you. And Sandy, I want to talk to you. You're not
I can tell because
Yeah, we got them on.
I wasn't certain about. I was like, why are hippies mad? Why are hippies mad? That was my question. People say hippies are bad.
yeah, the first like last time I joined. Yeah, here was the
Sorry.
I actually, like, they're gonna roll on your eyeball. That's terrifying. No, I'm literally.
I saw that face gonna have.
Yeah, I don't know if I have rehearsal today. I don't think I do, so I'm sorry.
But still, if you can be a name, like, go somewhere weird, like, that's even worse.
Sometimes I pause and have you not know. I'll just wait until I have you. But like, I guess when they die, there's like no oxygen. Like, so then like I wake up and like my eyes are like dying.
Why do all this work? I just go to church. And then
That's
for this
so
one,
weird.
you don't have to do this.
Did you do this? Did you just get
Put
one?
this here.
That also works.
Yeah. Why are we doing
Like,
that? So like for this, I get it. That's stupid. There's no problem.
Yeah.
Here, it's way easier. No, it'd be cost worth it.
What?
It'd be-
Okay, but like, like 6 months.
Yeah, I got it. But
Yeah, what the-
it's not for me to find the distance for wow, find theta, right? They close each other.
Yeah, so R cos theta equals 1.
Right.
Move everything to one side in your calculator. Negative 5 minus 3 cos x parentheses times cos x minus 1.
Right, so then you have theta, find theta.
No, yeah. So theta is basically the
Put
x.
you plug theta back into R.
Okay,
Find
it's
your
like
R, and then
$60 a month.
There's no, find the coordinate. This is what you have.
you write all this out.
No, your calculator is doing it very quickly. No, but what am I going to do?
Because I'm saying, it's going to go, find theta, plug theta back into R.
No. So you have.
And give it that.
Okay.
So,
But I need y. The point is either x and y or r and q.
try to define why you want it.
But like,
Yeah,
I was like, what the hell is going on? And then the Rob was like,
Because you're
oh,
right.
you don't get it, just get the
R is x. R is x squared plus y.
I was intending on like drama physics knowledge. Until I was like, I was like, still.
You mean product? Why power?
Apply back in. Then
We had AP last year.
You can do that. So that's maybe a little more. You totally do. Consequence, yes. But the only problem is it's cos squared. So you need power to power.
You're insane. Well, I didn't, like, I have
the answer is yes.
Oh.
They already give you why.
So we need the x value. But the x value requires you to know theta. So that's the cos theta.
Yeah, you're out.
Yes. Yeah. And then you use x there.
Yeah, I don't
I learned geometry.
No.
Like basics. Like I learned like sine, cosine.
No, x intercept sleeper. X intercept is theta.
My room saw me.
Yeah.
We usually
No, please understand why. Thank you. Please understand why. Well, that's negative 5 minus 3 cos x sine x plus theta. So the x intercept is not the x value.
very bad at algebra.
Silly boy. So keep in mind, as I asked you about, so you find the x intercept. That's giving you theta.
All formulas.
I still need x. And there's an x r cos theta. X. So that guy cos theta.
I didn't know. I thought we were graphing like
Cos
Oh
theta.
my God,
Cos
he did
theta.
spiral.
And we know
What the
theta.
frick is that? I was trying to back it into a heart.
2 minutes.
Sorry?
I was like, wait, where's the?
Where? They just gave you y equals negative 2?
When you take first, you're gonna do like cardinal.
Yes. I understand what's going on. I need x, and x is r cos theta. But you observe, I don't know theta yet.
Take notes from the book, and I'm like, this feels like this feels.
Because they don't give us. They just give us y equals negative 2. But I can set y equals negative 2, move everything to one side, and solve for theta.
No.
Then I find it.
I
We
don't
had a
need it.
really easy year rotation. Did you have bomb?
Yeah, but right now I have
This
to.
year.
I have
I mean, it was a blessing and a curse. Because
Where's-
you're not gonna learn
yeah.
anything, but it's an easy year.
The homework,
Or is it not ready?
it's not ready.
I do this.
Today, unfortunately,
I
BC is
never
ready for
thought
our
this was the beginning.
So I
Do
gather.
you ever push up your glasses like this?
Miss, what's your name?
You just don't like wearing glasses.
Oh yeah.
Not Robles. Miss Mendoza. You can start on today's homework if you want.
Why would this?
Here it is. So it's very graphing, calculator oriented. I believe it's so you can do the first few questions. Here's the marks. Where's Robles? Oh, here. Sam, do me a favor. Sit next to Robles. She's been absent for a bit. When she needs help, and you can sit behind it. Why did you start on today's homework?
Wait, so Gov and
So when she gets stuck, she'll sit clarification. I was meaning to go to Burby. No. Pam will write it. He can say.
Bombs wrong time.
Yeah, thank you.
Yeah, every single time.
But I started out. Again, guys, the homework is on the board. First,
I don't know how good this one is, but I think
It's just like VO. I guess that's that. Let's just change the last name. It'd just be like, because that's the integral.
Oh, what's the difference between an out part and cardio?
So out doesn't have
Oh,
like
so that's
average range. It has the numbers, and I was very. Wait, isn't there another one? Wait,
just have to
out
graph
cardio,
this, right?
like cardio and velocity from, like, in the and then yeah, all the parts are cardio.
2 minus F1.
Yeah.
So these are both
But no,
out.
this it'd be like via yeah.
See, that's what I should look like.
It's supposed to look fat, but I make it look more like a heart.
Because Bela always
Okay,
Does it look
yeah.
weird? When it asks you to change velocity, it always I remember having 3 of them though. So it's the normal one, the cardio. Oh, I remember now. So like integral like 1 to 2. If A and B are equal, then it's the cardio. If A
These are the cardio.
then the solutions. Yeah, it's just like.
Oh, okay.
And a cardio like touches the orange. And then if it's an out cardio, that means A is greater than. So like.
No,
This
these
A and
two
this
numbers,
B,
right?
yeah, this is greater than. That means it's just outside of the and then, yeah, you guys always like your interpretation. A is less than B. So, like, send the solutions like yeah, it always touches the origin.
So only out cardio never.
Can you access a photo library on Gmail?
And it doesn't have to be in the format like constant plus a trigonometric function.
Plus or minus?
Yeah, plus or minus. But
Yeah.
it's a constant plus or minus. Too much.
And then when you divide
And also, you know how x is equal to r plus that?
B is greater than A.
So because like x over r is equal to product, but then if they give you the r function, then you could have. Try it out. I don't know what's happening.
I don't know.
R plus X plus your O.
You need to try it out.
That's your
Are you asking if you should plug in R?
Yeah.
Because that's what we were doing for the problems in class.
For what?
That's what we were doing for the problems in class.
No, I mean like
It's
we're
already
trying to get the
done.
part when you're doing when you're fighting for x, but like
Yeah. So you would plug in R, so the original function that they gave you for R, into the R cosine theta.
It's like that innie. It's an innie. Yeah.
oh my god.
I like the
I mean, but John's still pretty cool.
Cool. Yeah.
Oh, so you only take like a picture of this part and then cropped it? That's so confusing for you.
Because he's my over two. Wait, well, it would just be exponential. It would just keep on expanding. It's just, I see something positive, right? So it's gonna be something black.
I don't get out. Oh my gosh, I was supposed to talk about Oh my gosh.
One half.
You have to crop that.